So today we're in section 1.1, solving simple equations. The word simple can be misleading sometimes, I think, because, you think, oh, well, every single problem that we work in this lesson is going to be easy. It's not necessarily the case. What they mean by simple is it's one step, okay? And with equations, we have what are called one-step equations, we have two-step equations, and maybe even more steps than that. So today you're going to see one-step equations. All right, so if you could go ahead and get out that notes packet that I gave you yesterday. All right, remember we're not taking notes the old way. We're using our fill-in-the-blank notes. So go ahead and just take those out of your binders. All right, I would suggest that you keep them stapled just because it's a lot easier to keep track of them if you're not like ripping one apart. And it's a big part of your notebook checks, guys. And remember, we're doing our homework in these packets also. So there's space in here for us to do our homework. All right? So everybody have your notes packets? All right, so the first thing we'll start with on some terms. Okay. All right, so the properties of equality. You have a few blanks here in your notes. That deals with adding, subtracting, multiplying, and dividing the same number to each side of the equation, and that produces an equivalent equation. What is it saying? You can do what we call opposite operations, okay, to get the variable by itself, and really that's our goal. That's our main goal, what we're trying to do. All right, so go ahead and fill those in. Then we're going to talk about this idea of opposites. All right, and that's where this reverso little activity comes in. So with a reverso, basically whatever I say, all right, so this action, I need you to tell me what the opposite action would be. So if I told you take 3 steps forward, what would you do?
Take 3 steps back.
3 steps back. What if I said turn the lights on?
Turn the lights off.
Turn the lights off. Step up on a chair. Step off the chair or down. Open the door. Close the door. So what I want you to do in those blanks on your notes, I want you to come up with a few of your own examples. An action and then the opposite action. So what we're doing is we're kind of training our minds on this idea of opposites, all right, which is a really important concept with solving equations. All right, so go ahead and write them down. Just a couple examples of an action and then the opposite action. All right, does anybody want to give me one of their examples? All right, I'm still learning names. Yes, what was yours?
Turn the TV on.
Okay, and then what's the opposite?
Turn the TV on.
There you go. Yes, come on.
Open the book and close the book.
There you go. Open the book, close the book. Yes.
Go to sleep, stay awake.
All right, go to sleep and wake up or stay awake. Anybody else? An action and then the opposite action? Darcy?
On a hat, take off the hat.
There you go. All right, so we don't have to, just really simple, all right? Just this idea of here's an action and then here's the opposite action. All right, so we have our properties of equality and then just those examples of opposites. All right, so let's review integers. All right, we know that integers are positive and negative. And last year, Ms. Vorpal taught you, if you had her, she taught you that nice little song.
Same side, add,
Right?
keep, different
Same sign, add and keep, different sign, subtract. Take the sign of the larger number, then you'll be exact. I don't sing it as pretty as her, but you guys remember? Okay? So what is that saying? All right, let's break it down. Same sign. Every number has a sign, and it's in front of the number. So 10 is what? Negative. 6 is positive. So I would say this is different sign, right? Different sign, subtract. So I subtract these numbers from each other. What is 10 minus 6? 4. And take the sign of the larger number, which is 10, negative. Then you'll be perfect. Yes, exact. So your answer is negative 4. All right? Is it kind of coming back to you a little bit? All right, this idea of positive and negative numbers. So let me ask you this. On number 2, do you have same sign or different?
Different.
What do you think?
Different.
Is 8 positive or negative?
Positive.
Is 16 positive or negative?
Negative.
It's negative. You say, well, that's a minus sign. I agree, but minus means negative. Okay? So, based on what you just said, they're different signs, right? So, what's 16 minus 8?
8.
8. And then 16 is bigger, so it's
Negative 8.
negative 8. All right? Calculators will not help us, guys. Okay? They're not much, right? They will help us to an extent on some things, but we've got to know these integers. All right, number 3, same sign or different?
Same.
You agree, Michael? You agree? They're both negative, right? Isabel? 9's negative and 6 is negative, so what's my rule? Add. 9 plus 16 is? 15, and yes, you're correct. Keep the negative. Keep the negative. All right, answer the last one if you haven't already. Negative 12 plus 5. Okay, so negative 7. Now let's talk about multiplication and division. This is a different set of rules with integers. We use our even-odd rule. We count how many negatives are in the expression. All right, so on number 4, how many negatives do you see? 1 negative. And because 1 is odd, my answer will be odd, or will be negative, okay? So then I just divide it. What's 10 divided by 5?
2.
2. So my answer is negative 2, all right? Now, how many negatives do you see in number 5? 2. 2 is an even number, so what's going to be the sign of my answer? Positive, right? It's going to be the opposite. All right, so if it's an even number of negatives, it's a positive answer. And then you just multiply. What's 3 times 2? 6. All right, how's everybody doing? Doing okay on this review? We'll do more review next week. We'll keep reviewing the integers because your book is kind of assuming that you know it. But we know that we need some review, right? So we don't need a brand new lesson on it, but we do need a refresher. All right, now number 6, how many negatives?
3.
So is my answer going to be positive or negative?
Positive. Negative. Negative.
Odd is a negative answer. What's 2? Don't add them. 2 times 2 times 2. 8. All right. Now, in the last one, we see division and addition. Order of operations says, what do I do first? Not parentheses, that's just, there's no, guys, there's nothing to simplify here with negative 5. So parentheses, the division comes first. Okay? So what is, use your rules, what's 30 divided by negative 5? Is it 6 or negative 6?
Negative 6.
Negative. 1 negative, guys. Odd number of negatives is a negative answer. Remember your even-odd rule. Even number of negatives is a positive answer. So this is going to be negative 6 plus 3. Okay, think for a second. Don't make a simple mistake. Maddox? Very good. Because 6 is bigger and it's negative, I subtract and my answer is negative 3. All right, how do we do on that? Okay, all right, so now we're going to go into solving equations. Okay, solving equations. And what we need to pay attention to here is what operation is connected to the variable. Okay, so on the first one, what operation do you see connected to the variable? Minus 7. Well, remember back to that example we just did about the opposites? Okay, what's the opposite of negative 7? Plus 7. And that's what we need to do to cancel it out. We need to get the variable by itself. My rule says whatever I do to one side, that's that property of equality. If I do it to the other side, I'm not changing anything. I'm simply getting x by itself. And x equals 13, okay? Now, I've seen some people today not writing the plus sign. You need to write the plus sign. It's not I'm not a mind reader. It's not understood. You need to write the plus sign. Is it in your notes? Did you write the plus sign? Okay. Now, does anybody remember how I could check my answer on an equation? Isabel?
13 minus 1 is 6.
Very good. Plug it back in. Okay, so what we're going to do is take this number and plug it back in. Your homework on Monday is going to ask you to do this. All right, so we have 13 minus 7 equals 6. So what is 13 minus 7? Actually do that subtraction. Don't just assume that it's right. What is 13 minus 7? 6. Okay, so it is true. 6, when I simplified it, equals 6. So I'm looking for two things, a boxed answer and a boxed checked answer. Let's look at the next one. 3k equals 12. 3k equals 12. What operation is connected to k? What operation is there? Is it addition?
Multiplication.
Just tell me. Multiplication, right? So what's the opposite of multiplication?
Division.
Okay, so what is it, guys? Division. Divide both sides by what?
3.
3. Okay, and look how I showed the division. Don't use a division symbol. Use the fraction bar, okay? A fraction means division also. It's just cleaner. All right, and then k equals what, guys? 4. All right, and then we're going to go back and check. Plug 4 back in. Don't just assume. Actually do the math. What is 3 times 4?
12.
So, yes, that is true that 12 equals 12. All right, how are we doing? Okay, now, I think most of us would agree, could we have done this in our head 3 times what number equals 12? You guys know that 3 times 4 equals 12. So why in the world would we do all this work? Do I just enjoy doing work for the fun of it? It's good. What does it start with? A P? It's good. Practice, okay? Because these concepts get a lot more difficult. Even in section 1.1, they start getting more difficult. So we need a good basis. Does that make sense? Quit looking at the clock. Got a lot of time left. It's okay. We're about halfway through. Come on, guys. Hang in there. All right. Any questions? Okay. So I want you to do these too. All right. So it's basically just the same thing, except we're just looking at a few more different, a few different scenarios. I want you to go ahead and solve these two equations. I'm going to walk around, kind of check on you guys, and see how you're doing. All right, so what did I do to both sides on the first equation? Add what? Add 17 to both sides. Okay, and was this same sign or different over here on the right? Different, so subtract and take. 17 minus 6 is positive 11. X equals 11, and then we check. And again, we don't just assume, we actually subtract 11 minus 17, and we get negative 6. Okay? Now on the second one, we're subtracting 3. So just watch your signs, guys. Is this same sign or different over here? Negative 3 minus 3.
Same.
Same, so we add and keep negative 6. All right. Any questions on that? Who got them right? Most of you guys did good? All right. Okay, so now let's move on to the next slide. Reviewing fractions. All right, so something is really important when we're adding and subtracting fractions. Does anybody remember what we have to have first before we can add or subtract a fraction? Addison? A common denominator. All right, so let's look at this first one. Are we good to go?
Yes.
Can we go ahead?
Yes.
And just as a refresher also, for the denominators, do we need to do anything with them? Just bring them over. We don't add the denominators. We leave them the same. So this negative out here in front of 3/4, that negative sign goes with the numerator. This means -3, okay? The denominator is never negative. You hear me on that? And I'll remind you of that. So what's -3 plus 1? -2 over 4. Can that be reduced at all? Yes. To what? -1/2. -1/2. And then that will be my final answer. So if I can reduce, I'm going to. All right? And we'll be good there. Now look at the second expression. Is this one ready to go? No, because I don't have an LCD. Go ahead and find your LCD and create your equivalent fractions. All right? If that's kind of a foreign language to you, you can hang tight or raise your hand. But I want to see who remembers how to find the LCD. Okay? And we'll check it in just a sec. All right, LCD, anybody? What is it?
12.
It is 12. It's the smallest number that 6 and 4 can go into. So now I'm going to bring down my signs, my negative and my positive. And how do I know what my numerators are going to be now?
Multiply the
How do I know?
numerator.
So what would I multiply the first one by?
2.
2, because 6 times 2 is 12, right? Whatever I had to multiply the old denominator by to get to the new one, that's what I multiply the top number by. So what's 5 times 2? 10. All right, here's something I need you guys to understand. All right, so look up here for a minute. Okay, -10 over 12. If you reduce that, it becomes -5 over 6. You see that? So I actually have not changed the value of the fraction. You see that? Okay? All I'm doing is making it a little bigger so the denominators can be the same. All right, so what would be my numerator in the second fraction? I heard it. 9, because 4 times 3 is 12. So 3 times 3 is 9. Again, do I do anything with my denominators? Adding wise? Nope, I just bring it over. So what is -10 plus 9? Is it 1 or -1? -1. Can that be reduced any further? Nope, so I'm done. All right, so you learned fractions last year, but maybe not with the negatives. All right, and you're going to see that quite a bit in chapter 1. So we just need to look at that. All right, let's come over here to multiplying and dividing. A different set of rules, right, for fractions. So my rule says with multiplying, I multiply my numerators and my denominators together. And guess what? My even-odd rule applies again. So how many negatives do I have in this expression? How many? 1. So the sign in my answer is negative. Okay, because there's only 1 negative. All right, so let's just multiply. This is easy, right? 3 times 1. 3. 4 times 4.
16.
And make sure your answer is negative. You can't reduce it anymore. Does anybody remember what happens when I'm dividing fractions? Raise your hand. Don't shout it out. What do I need to do when I'm dividing fractions? What do I need to do? Darcy?
What's the second fraction?
Do you remember the little acronym that we learned?
KFC.
Yes. I always think of chicken. Do you?
Yes.
Okay. KFC. So say it with me if you remember. Keep, flip, change. Keep the first, flip the second, change the sign. All right? And just remember, if it's negative, keep it negative. All right? So negative 9 over 12, I keep the first. I change the sign to multiplication, and I flip the second fraction. But remember, if it started negative, it needs to stay negative. Okay? Now, this is where we need to make sure we're taking any advantage of some shortcuts or reducing so we don't end up with huge numbers. Can I cross-reduce 9 and 4? Can I cross-reduce those? No, not easily. What about 6 and 12? Negative 6 and 12. All right, notice that 6 is negative. So when you cross-reduce it, you need to keep it negative. So negative 6 reduces to what?
2. No.
6.
One.
No, it reduces by 6, guys.
1.
Negative 1. Okay? And then 12 reduces to
2.
2. Okay? If you're reducing by 3, you might have said 2 and 4. That could work, but you're going to have to reduce at the end. All right? Now, the last trick here is make sure you watch your signs. -9 times -1. Okay? So you got to pay attention to your signs. This is numerator, -9 times -1. So what's that going to be?
Positive.
Okay, so I can hear you're saying the answers, but we're still a little shaky on it. That's okay, but we need to firm that up, okay? If there's 2 negatives, that's even, it's a positive answer. So we need to make that a little more automatic in the next week or so. All right, so 9 over, what's 2 times 4? 8. You can leave it improper. Can it be reduced? No. You do not have to make it a mixed number. You can leave it improper. But if it's something like 2 4s, like we had up here, you need to reduce it, okay? Do you understand the difference? All right, how do we do on fractions? Kind of coming back to us, LCD is important. All right, I tried to keep it basic for this review, but obviously it's going to get more complicated. All right, and this is where we're going to stop. Our other 2 classes stopped here, so I don't want to kind of get off track with what they're doing. We'll do a little bit of classwork to kind of fill in the rest of class, and we'll finish up our notes on Monday.